Hey, thanks for joining me today. We're going to talk about square roots and the Pythagorean theorem. Now, this is going to be tricky, but square roots are not as difficult as they seem, and I don't want to go into too much detail, but the square root is just the opposite of squared. So if you get that down, then you're going to be just fine. So for example, if I say, take a number, um, let's say um, let's say 6, and I square it. 6 squared. Well, 6 squared is 36. That's 6 times 6 is 36. Well, then the square root is the operation I use to go from 36 back to the original number that I squared, which was 6. So the square root undoes the squaring. So the square root of 36 is 6. That's how square roots work. Okay, so then I could just see each one of these as a puzzle. It's asking a question. Square root of 25, what number times itself, or what number squared is equal to 25? That's what the square root is asking. What number times itself is equal to 25? And I hope you said to yourself, the answer is 5. Okay, now it can get harder. How about this one? What's the square root of 49? This may be a little bit harder, and so I want us to think about ways to, right, because the first method I just showed you was kind of the guess and check method. It was just kind of, can you cleverly think it out? But what I really want you to do when you see a square root is I want you to have in your brain, and maybe even on your paper, in your notes, or you can just make this up every time if you want to. I want you to have this list. And let me write the list, and you try to guess what the next number is. So the first number is 1, and then 4, and then 9, and then 16. Now, what's the next number? Do you know? It's 25, and then 36, and then 49, 64, 81. Do you know what the next one is? It's 100. We can keep on going. 121, 144, and I'm going to stop there. I think that's enough. If you have these numbers memorized, you will go a long way in algebra. Here's why. Where did these numbers come from? Let me show you in blue. 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16, and so on. So 5 squared is 25, 6 squared is 36, and 7 squared is 49. And there we have our answer to what's the square root of 49. It's 7, because 7 squared is 49. Now, that's how you make the list. How do you use the list? This list is going to be really, really useful. Finish off this. 11 squared is 121, and 12 squared is 144. Now, here's how this list is useful. These are called perfect squares, and if you just have them memorized, or just kind of vaguely memorized, you will be able to simplify square roots really fast. The square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3, and so on. So this list is going to be really helpful for us. Notice that I'm changing the blue numbers no longer apply because I'm adding the square root signs here. But this is the real list that you want to have in your brain and or in your notes. And anytime we're dealing with square roots, this list will be super helpful. Okay, so we did the square root of 49. That's easy. Now, what's the square root of 1? I hope you remember that the square root of 1 is 1. This is the one that everyone forgets. So I just want to put that out there that everybody forgets this. Now, we're not going into great detail about square roots in this class. This is it, really. I think this is all we're going to talk about. But we could make up a few observations about deeper rules if we wanted to. But for now, I'll just note that if I say, what's the square root of 1/9, I can think about it as, what's the square root of 1? That's 1. And what's the square root of 9? That's 3. I have two different places on my list that I look to find that information. And that's true because 1/3 times 1/3 equals 1 times 1, which is 1, and 3 times 3, which is 9. So I could say that 1/3 squared is 1/3 times 1/3, which is 1/9. And so the square root of 1/9 takes me back to what I started with, 1/3. All right. Well, piece of cake, right? You would think so until we get to this point. What is the square root of 3? And now we're going to run into some trouble. Because as I look at my list here, I have the square root of 1, and I have the square root of 4, but I don't have the square root of 3. The square root of 3 is somewhere in between the square root of 1 and the square root of 4, and I don't know exactly what that is, but I can tell, and this is where my list is useful, I can tell it's between 1 and 2. So if you just need a real quick estimate of the value of a square root, you can use the list to say, well, it's between 1 and 2. So I could say, well, maybe it's 1.4 or 1.5 or something like that. Okay, now if we really want to know, we can look up on a chart, and that's all we're going to do in this class, look up on a chart or on a calculator. So let me pull up my calculator using this one that's on my computer. I'm going to type in 3, and then I have to hit the square root button, and on my calculator I have to say second, and then it switches over to this button, which was squared, becomes the square root. So I'm going to hit that, and I get 1.732. Okay, so I was wrong about this. 1.732. Now, notice that it actually didn't say 1.732. It said 1.7320508075688. This calculator is amazing. It gives me so many numbers here, but notice that this is actually not that big a number. It's 1 and a little bit, 1.7, and each one of these numbers represents a smaller and smaller, teeny tiny piece of a number. So this number is what we call an irrational number. It's a number that goes on forever. Notice the calculator only goes so far, but this number itself actually goes on forever. We won't worry about that, but just to note that when you're doing square roots of non-perfect squares, you're going to end up with a decimal number, and you'll have to have some rounding involved. So typically we'll tell you what place value to round to, but if nobody says, I would say the hundredths place or the thousandths place is safest. Maybe 4 decimal places if you want to be really precise. Okay, let's put the calculator away for a minute and do the next one. The square root of 18. We're going to do the exact same process as before. We're going to look for where would the square root of 18 fit in on my chart. The square root of 16 is 4, the square root of 25 is 5, the square root of 18 is going to be right in between, but it's actually going to be a lot closer to 4 than it is to 5. So I think the square root of 16 is going to be 4.1 or 4.2. That's my guess. To know for sure, I have to get out my calculator and type in 18, and then I'll do the second button, and I'll hit the square root button, and I was wrong again, 4.2426. 2426, and that's nice and precise, and that will be my answer. I wanted to get rid of the 1 there. Okay, let's scroll down, and we've got another question here. What's the square root of 50? Let's do it one more time. The square root of 50 is going to be just a bit bigger than the square root of 49. Square root of 49 is 7, so the square root of 50 is going to be 7 point something. I'm not even going to guess now, although I have an idea. I'm going to type in 49, hit the second button, square root. Oh, haha, I made a mistake. Did you see that? I said I had 49 on the brain. We're trying to find the square root of 50. Square root of 50, so 50 second square root, and 7.0716. So that would be 0.71, oh, 06, so 0.711. I'm going to round up, 0.711. I rounded the 06 up to 1. And there we have it. Okay, so that's how we estimate, or that's how we get a decimal answer of a square root. You really can't do it without a calculator. There are some old-fashioned methods of finding square roots that are more precise and more complicated. We're not going to worry about those at all. Most modern people just use a calculator after a bit, and when we get to algebra, we'll study some more methods for dealing with square roots. So we're not done with this by any means, but this is just an introduction. Okay, finally, last thing, we're going to talk about Pythagorean theorem. And the Pythagorean theorem is really cool. It goes like this: Pythagorean theorem. It says a squared plus b squared equals c squared, where a and b, I probably should use the same case, a and b are legs, and c is a hypotenuse. Hypotenuse. I didn't spell that very well, but you can see it right here, hypotenuse. And what on earth does that mean? Well, the Pythagorean theorem refers to the lengths of sides in a right triangle. Right triangle. So a right triangle is a triangle that's made up of a right angle. And then there's a long side that we call the hypotenuse. Hypotenuse. Okay. The hypotenuse is the long side. It's across from the right angle. So we have a right angle here. The across from that is the hypotenuse. And then the other two sides are called legs. This is a leg, and this is a leg. Now, in this question, we were given the two legs. We said one of the legs is 9, and one of the legs is 12, and the question is, what is the hypotenuse? Okay, well, according to the Pythagorean theorem, if you take the two legs, 9 and 12, and you square them, and then add them together, that will equal the hypotenuse squared also. So 9 squared, 9 times 9 is 81. 12 squared, 12 times 12 is 144. If we add those together, we will get c squared. Okay, let's do that. Let's see, 1 plus 4 is 5. 8 plus 4 is 12. Carry the 1. 1 plus 1 is 2. So c squared is 225. Now, the whole point of learning about square roots was so that we could do this. We want to find out what number squared equals 225, and the tool that answers that question is the square root. The square root is the opposite of the squared. So when you square root a squared, it cancels out the squared, and you're left with just the number without the squared, and that's what we're looking for. C, the square root of c squared is c, and now the square root of 125 is going to be the answer for c. Well, what is the square root of 125? We could get our list out, but our list was not long enough. I didn't go far enough. So I'm going to have to go on my calculator, 225, hit the second button, square root, and it's 15. So it turns out that if one leg of a right triangle is 9 and the other leg is 12, then the hypotenuse is 15. Sometimes we abbreviate hypotenuse with HYP. I highly recommend doing that. Alrighty, let's do a similar but not quite the same question here. I'm going to give myself a little more room. And the next question says one leg is 12 and the hypotenuse is 15. We can draw that picture. It would look somewhat like this. 15 here, 12 here, and then the question mark, or maybe we'll call this A, is that other leg. So I'm looking for the other leg. And so let's plug it into the Pythagorean theorem. And remember, Pythagorean theorem, the two legs are squared. So a squared plus 12 squared equals the hypotenuse, which is 15 squared. We'll go ahead and do the squareds first. So 15 squared, we just said, is 225. 12 squared, 12 times 12 is 144. And we have the a squared. Now we're going to subtract 144 from both sides. What's being done to a squared? We're adding 144. I wrote an equal sign instead of a plus sign, and it's kind of like I forgot to hit the shift button on my keyboard. Alright, so 144 minus 144 is 0, plus a squared is a squared. 225 minus 144, let's see, that's going to be a 1. 4, 12, oh, not enough, so we need to borrow. 12 minus 4 is 8. And 1 minus 1 is 0, so a squared equals 81. The way we undo the a squared is we do the square root. The square root of a squared is a. And the square root of 81, that's our list up there. I hope you have your list memorized. The square root of 81 is 9. So a equals 9, or the other leg, the missing leg, is 9. And now we can see that the two triangles we were describing are the exact same triangle. 9 and 12 were the legs, 15 was the hypotenuse, but the Pythagorean theorem describes the relationships between the lengths of the sides, the legs and the hypotenuse, in this way, and it works for all right triangles, not just this one. I hope you have fun with this, and have a great day.